Hey, my name is Anthony Gray, and I'm going to be going over a simple dynamics problem featuring a teacup ride that you would find in a local fair. Now on the screen is the schematics of this teacup ride printed out. You're going to see the big circle represents the platform and the little circle represents the teacup. The M is the person in the teacup, and O is the center of the platform. And what the problem states is we need to describe the center of curvature of the occupant when the platform has a angular velocity of theta dot and the teacup has an angular velocity of phi dot. And it's important to note that these angular velocities are both relative to the ground and they're both equal to each other. So the center of curvature for the occupant with respect to the ground is going to be the origin of the platform. And this is because the teacup is rotating at the same angular velocity relative to the ground that the platform is rotating. So from the reference point of the Earth, the teacup and the platform are not rotating relative to each other, and therefore the center of curvature for an occupant would in fact just be the origin. The next reference frame to consider is the reference frame of the platform. So imagine that you're just standing at the origin and looking out at the teacup as you spin around. And the center of curvature for the occupant from that reference point is there is no center of curvature. It's a trick question because from your viewpoint, the occupant is not moving at all. The teacup is not moving at all. In fact, the only thing moving to you is the Earth, which would be spinning around you very rapidly. In order to illustrate this, I have some footage of my brother spinning on a merry-go-round. Unfortunately, I did not have access to a teacup ride, so I had to make do with a merry-go-round. My brother can represent the teacup, and you can think of one of his arms being the occupant. And the first clip will be from the reference frame of the Earth, and then the next clip following will be from the reference frame of the platform, and we'll go ahead and jump right into that. So as you can see here, his angular velocity is exactly the same as the platform's relative to the Earth, and if you look at one of his hands, the center of curvature of his hand is the center of the platform. Now in this next clip, I am standing on the very center of the platform, and you're going to see him jump on, and relative to me, he's not moving at all. He's not rotating. His hands are perfectly still. His hands represent the occupant, and all that's moving is the Earth, which is spinning around us. So if you were to describe the center of curvature for either him or his hands, which represent the occupant, it's zero. He's not rotating at all. He's perfectly still, as am I, and the only thing that's rotating is the Earth. In summary, from the reference frame of the Earth, the center of curvature of the occupant is the center of the platform, O, and from the reference point of O, the platform, there is no center of curvature. Have a good day.